The last video introduced computations associated with the normal distribution. In this video, we will walk through several more examples just to make sure that we're able to do those computations. And so, for example, heights of adult American males are known to be normally distributed, mean of 5'9", standard deviation 4 inches. Again, I got those data from the internet. The question is, what percentage of adult males are 5 foot tall or less? First step, always draw a picture. We're trying to get this course cross-listed with the art department so you can get A credits as well as Q credits. No, seriously. Drawing a picture will help us keep track of the areas that we need under the curve. And in this problem, mean of 5'9", standard deviation 4 inches, percentage of the population 5 foot tall or less. Here's our picture. Heights are running along the horizontal axis. The mean is 5'9", 12 inches in a foot, so 5 foot is 60 plus 9. The mean is 69 inches. Standard deviation is 4 inches. 5 foot would be 60 inches. We're looking for this red shaded area under a curve. We could compute the z-score. We observed 60, we expect 69, standard deviation was 4, minus 2.25 means that this individual is 2 1/4 standard deviations below average. And then the standardized norm function gives us this probability. Alternately, we could use the unstandardized form of the function, get 60 inches when the mean is 69 and the standard deviation is 4. Either way, we get the same number. Basically, it's telling us that about 1.2% of adult American males are 5 foot tall or shorter. Let's do a second example. Height of American males again, same data. But let's go to the other end of the distribution. What percentage of adult males are 6 foot tall or taller? I'm going to ask you to pause the video at this point. Take a minute, work through a solution. Once you've got that solution, unpause the video and we will walk through it so you can check your work. So pause the video, find a solution to this problem. I trust you began with the important first step, that you began by drawing a picture. Picture looks like this. We're looking for 6 foot, i.e. 72 inches or more. And we could compute the z-score. If you're 6 foot tall, you're 3/4 of a standard deviation above average, corresponding with a probability of 0.7734. Or you could directly say 72 inches when the mean is 69 and standard deviation is 4. Again, true. Give you the same answer. You can either type this in directly if you're familiar with the syntax of those functions, or you can use the function wizard to get there. Either way is fine. There's only one minor problem here. That answer is not wrong. It's such a harsh negative term. It's suboptimal. Why? Look at your picture. The function in Excel gives us the area from a certain point on down. So the 7734 is this area. the chance of being 6 foot tall or less. We want the red area. We want the area up in here that is 6 foot tall or more. How do we find that? Well, we take the entire curve, 100%, 1, subtract off the stuff we don't want, and we're left with the stuff that we do want. In other words, 22.66% of the population is 6 foot tall or taller. Let's work through a third example. Look at the women's data this time. Mean is 5'5", standard deviation is 3.5. The question is, what percentage of adult females are between 5 foot and 6 foot tall? Again, I'll ask you to take a minute, pause this video, work through the solution on your own. You learn a lot more by attempting problems yourself than by watching me work solutions. Pause the video, attempt this problem, work through it for solution, then unpause the video and we will be able to check your answer. Take a minute, work through this problem. Okay, but we will draw a picture. Always draw a picture. We're looking for the area between 60 inches and 72 inches, 5 foot and 6 foot. We could use a standardized approach, find the z-score. 6 foot tall, 72 inches is 2 standard deviations above average. 5 foot, 60 inches is 1.4 and some change standard deviations below average, and find the standardized probabilities there. Or we could type in directly using the unstandardized formulas. Either way, we'll get to those numbers. Once we've got those numbers, what do we do with them? We subtract them. Why? Let's look at our picture. We computed an area for 6 foot for 72 inches, and this area, shaded in red, was 0.977. We also found an area shaded in blue, this area here, for people who are 5 foot or less. So we're starting with the red shaded area, and we're going to get rid of the stuff that we don't want, the blue shaded area, and that leaves us with just this area here, 90%. Again, use the picture. This is why we draw a picture, to help us keep track of what we need to include and what we want to exclude from the probability. In sum, for this class, you should be able to find probabilities associated with the normal distribution. I prefer that you use functions in Excel. We've walked through some examples of using those. However, if you already from a previous class are familiar with and comfortable with the use of printed tables, that's perfectly acceptable for purposes of this class.